Similar shapes. Part 2. What is a similar shape? This is a shape, and this is a shape. However, they are the same size this way and this way. So these two are the same size and shape. So they're congruent. They're not similar, congruent. Here's another shape. And this shape. Nope, don't even look the same. They are not similar, and they're definitely not congruent. Here's this shape again. Here's a bigger version. Now, in order for these things to be similar, the angles have to be the same. So I've taken the liberty of measuring them all, and sure enough, they're all the same. This is 35, 35, 130, 132, 42, 40, 30, 30, 105, 105. We can also check by just holding them up to each other. See how they match? It's 105. Put it over here, and it matches. Same thing here. Hold it there. Same, little off, drawing error. And here, same thing. And over here in the corner, the same. And maybe just a little off. It's there, drawing error. So that's part one of being similar. The other thing is they have to have corresponding sides that are in the same proportion. So if we take a look at this one here, we can measure it real quick, and what we'll end up coming up with is 18. And then this one will be 9. So this one is 18, this one is 9. So the proportion between 18 and 9 is 2. So this is half of that. If this is the case, and in order for this to be similar, this side also has to be half. And we have 16, and then we have 8. So we have 16 and 8. So we have this corresponding side that is the same ratio. This side here is 12, so this side here should be 6, and it is. So this is 12, and this is 6. Then we have this side here, which is 4. So this side should be 2, and it is. So 4, 2, and the final side. This side is 12, so this side should be 6, and it is 6, 12. So these two shapes are similar. They're similar because all the interior angles are congruent, and the corresponding sides are of the same proportion. So if we're looking and thinking about what I'm just saying, is this: in order for a shape to be congruent, two things have to happen. All angles must be congruent. And then the next one is all corresponding sides share the same proportion. So all angles must be congruent, all corresponding sides share the same proportion. So this shape, we have all congruent angles, and the ratio between these two is 2. So if we take the little one and multiply it by 2, we get the big one. So this shape is similar. here we have another shape. And if we measure this one, we're going to have 7, and I believe the other side is 11. So in order to find a shape that is similar, we have this one. 2 things have to happen. 1, all of the angles must be the same. In this case, we have 90 degrees all the way around because it is a rectangle. So we have condition 1. All interior angles are congruent. The next thing is, are they proportional? So we're going to use our handy dandy ruler. That's 7, and this is 14. So 14. So the ratio is 1 to 2, or our multipliers times 2. 7 times 2, 14. Let's check the other side. This is 11, so times 2 should equal 22. Should equal 22. This is 20, so the actual side is 20. So even though these look alike, they are not similar. When a shape is similar, another way to think about it is that the thing is zoomed in and out. So if we take the one that I drew earlier, look at that. We zoom up, and it's almost the same. It's like zoomed out and zoom in, zoom out. That's what a similar shape is. Zoom in, zoom out. Or watch this. When the drawing is done this way, it's easy to see what the corresponding sides are. This side is corresponding to this side, this one to this one, that one to that one. Now, how do we know it's similar? Well, I've already measured this. So this is 2 centimeters, and this is 5 centimeters. This is 3 centimeters, and this is 7.5 centimeters. So if we were going to check whether or not these are similar, we would actually check, and using the cross product, we'd do a little math, and we would check. We would take the ratio of these 2 corresponding sides, 2 centimeters, 5 centimeters, and then take these 2, 3 centimeters, and 7.5 centimeters. Take the cross products. 3 times 5 is 15, 2 times 7.5 is 15. They're equal. So these 2 are similar. All the angles are the same, all angles are congruent and all sides are proportional. Now I wrote the word scale up and scale down because there's something called a scale factor. And the scale factor is, another way to look at it is, how much bigger did this thing get? Or how much smaller did it get? Notice how I drew the arrows this way. If we scale up, we're going to find the multiplier. And we can use our two numbers that we have here. So if we take 7.5 and divide it by 3, we're going to get 7.5 divided by 3. 2.5. 2.5. That is our scale factor. So whatever measure this is, 2.5 is going to get us this way. So if we're wanting to go this way, scale up for this one, it is our scale factor is 2.5, meaning that this, each side, is 2.5 times bigger than this one. Now to go the other way, it's the same thing. Math is reversed. 3, 7.5, and that 3 divided by 7.5 is 0.4. And the reason I'm using a calculator is this can be looked at as the reciprocal. 0.4, this is 2.5 over 1, or this can be written as 2.5. Will that come out the same? 1 divided by 2.5, 0.4, same thing. So when you go this way, you have a scale factor this to go up. But if you are reducing and you know the scale factor for an increase, the scale down is a reciprocal of the scale factor. Or in this case, to go this way, it is 2.5 or 0.4. 7.5 times 0.4 is 3. That is the scale factor. That's pretty much it. You cannot have a negative scale factor. Just because things are getting smaller doesn't mean they're going negative. That means that they are incrementing by a smaller amount. No negative scale factors. Less than 1, greater than 1. So here, scale factor zoominess. Scale factors. Z of 1, same thing. Greater than 1, it's getting bigger. Bigger. Less than 1, smaller. Scale factors, it is never 0. A scale factor of 0 means the thing disappeared. So 2.5, 0.4. Scale factor of 0 would look like this. This we're scaling. 0, gone. So no zeros.